See this problem. Find the Fourier series to represent the function f of x equals to x sin x, where minus pi less than x less than pi, and deduce a relation. So here also they gave us a function f of x equals to x sin x, and they gave an interval minus pi comma plus pi in a different manner, such as here they mentioned x lies between minus pi and plus pi. Nothing but they gave us the interval minus pi comma plus pi. So whenever you see our interval is minus pi comma plus pi, which formula we have to choose? Yes, it is second formula. If it is second formula, as usual, we have to check whether the given function is even or odd. Let us see that. Just by replacing x with minus x, we will check whether the given function is even or odd. Here, put x equals to minus x. We get minus x sine minus x, sine of minus x. Nothing but x sine x, which is our given function f of x. So what we got? We got f of minus x equals to f of x. Nothing but even function. If it is even function, we have to follow the formula. Here it is. F of x equals to a naught by 2 plus sigma n equals to 1 to infinity a n cos nx. Here also we have to calculate a naught and a n values by substituting your function f of x here. Okay, now first let us write. Given function is f of x equals to x sin x in the interval minus pi comma plus pi. Okay, clearly the given function is even. So what will be our Fourier series expansion? Our Fourier series expansion by using this formula f of x equals to a naught by 2. By using this formula, we will get, in place of f of x, we have x sin x. So just substitute it. We got x sin x equal to a naught by 2 plus sigma n equals to 1 to infinity a n cos nx. Let us give a name equation 1. Okay, now we will calculate a naught value and a n value. Let us see the formula for a naught. What is your a naught? A naught equals to 2 by pi integral 0 to pi f of x dx. Okay, now substitute x sin x in place of f of x. We are taking integration by parts. We get minus x cos x plus sin x over the limits 0 to pi. Let us substitute upper limit first. That is minus pi cos pi plus sin pi minus 0 lower limit, substituting lower limit, minus 0 cos 0 plus sin 0. You know the values. What is cos pi? Yes, minus 1. Sin pi, 0. Cos 0, 1. Sin 0, 0. Just substitute these values here. We get minus pi into minus 1 plus 0 minus 0. Finally, you got, after cancellation pi, we got 2. So, your a naught value is 2. What we obtain? A naught equals to 2. Now, move to find out a n value. Write down the formula for a n. What is a n? A n equal to 2 by pi integral 0 to pi f of x cos nx dx. Replace x sin x in place of f of x. Okay, now a n equals to 2 by pi integral 0 to pi x sin x cos nx dx. Now rearranging this one, we get 1 by pi integral 0 to pi x into 2 sin x cos nx. This is of the form 2 sin a cos b equals to sin a plus b plus sin a minus b. So what is a here? Here a is x and b is nx. Okay, now substituting or now by using this formula, we get x into sine a plus b means x plus nx. We can write it as 1 plus n into x plus sine 1 minus n into x. So, here you got 1 by pi integral 0 to pi x into sine of 1 plus n into x plus sine 1 minus n into x dx. Now, by using Bernoulli's rule, we will calculate the integration. Let us see what is our u. Our u is x. And what about our v? Our v is sine 1 plus n into x plus sine of 1 minus n into x. Okay, now let us see. Integral x into sine 1 plus n into x plus sine 1 minus n into x dx. This is u and this is the total one is v. This can be written as x into integration of the first one. What is integration of sine? Minus cos. So this can be written as minus cos of 1 plus n into x by 1 plus n plus minus cos 1 minus n into x by 1 minus n minus derivative of x is 1 and integration of the second one, that is minus what is integration of cos? Sine. So sine 1 plus n into x by already we have 1 plus n here. So we get 1 plus n whole square minus sine 1 minus n into x by 1 minus n whole square over the limits 0 to pi. If you take here, the limits are 0 to pi. Okay, now here 1 by pi minus x cos 1 plus n into x by 1 plus n plus cos 1 minus n into x by 1 minus n plus 1 into sine 1 plus n into x by 1 plus n whole square plus sine 1 minus n into x by 1 minus n whole square over the limits 0 to pi. Now, you have to substitute the upper limit and lower limit. We get this value. Okay, after substituting the lower limit, we get 0. The second part will be 0. Now, we'll see. We have to calculate what is cos 1 plus n into pi and cos 1 minus n into pi and sine 1 plus n into pi and sine 1 minus n into pi. Let us see what is cos 1 plus n into pi. Just recall these 4 formulas. Your formulas are cos a plus b. What is cos a plus b? Cos a cos b minus sin a sin b. Cos a minus b, sin a plus b and sin a minus b. Using these 4 formulas, we will calculate the values of cos 1 plus n into pi and cos 1 minus n into pi, sin 1 plus n into pi and sin 1 minus n into pi. Let us see that one. See here, cos 1 plus n into pi can be written as cos, just multiply with pi. Okay, cos pi plus n pi. This is your A and n pi is your B. Which formula we have to use? Yes, cos A plus B. So by using this one, we got cos pi cos n pi minus sin pi sin n pi. Okay, what is cos n pi? Minus 1 power n. What is sin n pi? 0 for all values of integer n. Now, substituting those values, cos pi is minus 1. What is cos pi? Minus 1. And cos n pi minus 1 power n. We get minus 1 power n plus 1. Okay. So, cos pi cos n pi equals to minus 1 power n plus 1 minus sin pi and sin n pi, nothing but 0. So, we got minus 1 power n plus 1. Now, so we get cos 1 plus n into pi is equals to minus 1 power n plus 1. Similarly, we will evaluate cos 1 minus n into pi is nothing but minus 1 power n plus 1. Now it remains to prove sin 1 plus n into pi. Let us see that. Sin 1 plus n into pi, nothing but sin pi plus n pi. By using the formula sin of a plus b, this equals to sin pi cos n pi plus cos pi sin n pi. Okay, what is sin pi? Nothing but 0. So the first part is 0 plus. Here we have sin n pi. What is sin n pi? 0. 0 into cos pi? 0 itself. So 0 plus 0, we got 0. So we finally got sin of 1 plus n into pi equal to 0. Now see the second one. What is sin 1 minus n into pi? Nothing but sin pi minus n pi. This can be written as, by using the formula sin of a minus b, sin pi cos n pi minus cos pi sin n pi. Nothing but 0. So we got sin 1 minus n into pi equal to 0. Okay, now substituting these two values here, we get 0 plus 0. So after simplification, we got our an value equals to 2 into minus 1 power n by 1 minus n square. Here n not equals to 1. Okay, what happens if n equals to 1? Okay, we have to calculate for n equals to 1. So let us see. For n equals to 1, we have to find out a1. By using the formula an itself, we will calculate a1. So let us write the formula for a1. Just replace n with 1 in your formula an. An equal to 2 by pi 0 to pi f of x cos nx dx. If you put n equals to 1, we get, what is a1? a1 equals to 2 by pi integral 0 to pi f of x cos 1 into x, nothing but cos x. So cos x dx. Now again substituting our function f of x equals to x sin x. We got a1 equal to 2 by pi integral 0 to pi x sin x cos x dx. Again by using the formula. What is 2 sin x cos x? Nothing but using the formula sin 2a is equals to 2 sin a cos a. So we get sin 2x. Okay. So we have 1 by pi integral 0 to pi x sin 2x. Using Bernoulli's rule, we will get the value minus 1 by 2. We obtain a1 value equal to minus 1 by 2. Is it clear? Now we will substitute a0, a1 and an values in equation 1. We get x sin x equals to a0 by 2 plus sigma n equals to 1 to infinity an cos nx dx. Now this equals to, what is your a0? 2. So 2 by 2 plus a1 cos x. What is your a1? Minus 1 by 2. So minus 1 by 2 cos x plus, next the summation runs from 2 instead of 1. We already calculated a1 value. So your summation starts from n equals to 2 to infinity. So 2 into minus 1 power n, 1 minus n square cos nx. This is our result. Okay. What is our final value? Fourier series expansion. X sin x equals to 1 minus cos x by 2 plus 2 into sigma n equals to 2 to infinity minus 1 power n by 1 minus n square cos nx. Our problem is finding the Fourier series expansion and then deduce this relation. What is our relation? What we have to prove? 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 so on equals to 1 by 4 into pi minus 2. This we have to prove. Here we have to choose the value of x. For what value of x we will get that deduction. Okay. Now here I am substituting x equals to pi by 2. I am substituting x equals to pi by 2 in equation A. We get pi by 2 sine pi by 2 equals to 1 minus, in place of x, pi by 2. So, cos pi by 2 by 2 plus 2 into sigma n equals to 2 to infinity minus 1 power n by 1 minus n square cos n pi by 2. Okay, cos n pi by 2. After expanding the summation, we get pi by 2 minus 1. You are taking minus 1 this side. That is pi by 2 minus 1 equals to 2 into this one. Okay. Now here cos 2 pi by 2. Nothing but cos pi. You know that cos pi is minus 1. Just represented like this. Now what is cos 3 by 2? Here we can use the formula cos n pi by 2. What is cos n pi by 2? Its value is 0 if n is odd, and it is minus 1 power n by 2 if n is even. So, by using this formula, we get cos 3 pi by 2 equals to 0 and cos 2 pi equals to 1. So, after substituting, we get the result. Is it clear? I am giving you some practice problems on this concept. Please do them yourself. I am just giving you some hints to solve these problems. Okay. Now, let us see the first practice problem. Find the Fourier series of pi square minus x square in minus pi comma plus pi. Here the interval is minus pi comma plus pi. So, we have to use second formula and check the condition. Pi square minus x square is even or odd, just by replacing x with minus x. So, we got pi square minus x square is nothing but, check it. Yes, it is even function. So, we need to calculate a0 and an values and substitute these a0, an values in your formula. Okay, that is f of x equals to a0 by 2 plus sigma n equals to 1 to infinity an cos nx. In this formula, you have to substitute a0 and an values. You get the answer. Now, let us see the second case. Your second problem is expand the function f of x equals to x square by 4 as a Fourier series in the interval minus pi comma plus pi. They mentioned the interval and function directly. So, without any confusion, let us check the function even or odd and select the formula and evaluate it. Now, let us see the third problem. Here they gave one deduction. That is, first read out the problem. Obtain the Fourier series for the function f of x equals to mod x. F of x equals to mod x. In the interval minus pi less than x less than pi. They gave the interval in an indirect manner, that is x lies between minus pi and plus pi. So, your interval is minus pi comma plus pi. So, we have to use second formula. So, check whether the given function is even or odd. Clearly, you all know what is the mod function. Here, the mod function is an even function. So, you have to choose this formula only. So, you need to calculate a0 and an. Just substitute it, we get the value of Fourier series expansion and select the suitable value of s, you get this result. By observing the value itself, we can conclude that which value we have to select. Okay. Now, see the last problem. Here the function is x cos x and the interval is minus pi comma plus pi. Thanks for watching the video till the end.